This
I'm all
conference will now be recorded.
so have your breakfast between before they join, right? We'll continue in 5 minutes.
Sure, Naveen.
Thank you.
This conference will now be recorded.
Okay. So yesterday we discussed about factory pattern, right? We compared this with JDBC to uh, make you understand that. So basic the use of factory method is the basic use of factory method is whoever is going to use the factories, right? Their implementation is independent of independent of provider implementation. Okay, so that is the benefit with factory. Factories will doing what? Instantiation logic also they will hide. Driver manager dot get connection is a factory method. Internally it is creating object, but we don't know what is the logic behind creating the connection object. That is the one thing. Factory pattern or factories will do what? Generally they will create objects, but we don't know how they are creating it. Okay, so the factory can create a single object or multiple objects or a proxy object, any kind of object internally it can create. Finally it will deliver it into in the form of interface. Always factories will deliver objects in the form of interface, so that the subsequent code will be independent of implementations. Okay, so the factories are useful to create objects, to create other class objects, not itself its own object. Driver manager is a class. Get connection is a method in driver manager class. It's a factory method. This factory method is creating object for connection class, not for itself. So factory itself, it will not create its own object. The factory's job is they need to create other class objects. Factories need to create other class objects, and that other class objects need to return in the form of interface. Okay, so that whatever other class object you are creating, that object instantiation logic can be hidden, and that will be delivered always in the form of interface, so that whatever subsequent code you are writing hereafter your code is independent of implementation providers. Okay, your code is independent of implementation providers. In which scenario you need to do this, in which scenario you need to implement it, in which scenario you need to implement this. Okay, so consider you are implementing application with some controller classes and business classes and DO classes. Okay, so here your DO class wants to connect with the database for doing CRUD operations. It want to connect with the database. For doing CRUD operations. So now I have here one database Arkil. I have an Arkil database. So currently I'm using Arkil. So in future I have a thought that I may need to change the database from Arkil to MySQL. So in future I may change the database. I have that option in my mind that I want to implement my application. My application should able to shift the database, should able to change the database. Today I started designing my application with Arkil. In future I want to change it to another database. So that flexibility I want to give it to my database DO class. DO class will handle all the CRUD operations here. I want to give some flexibility to my DO class. I want to give some flexibility to my DO class. My DO class should able to easily change. My DO class should able to easily change database. Okay, so for that one, I want to implement a factory class. Basically, for doing CRUD operations, we can use data source. Data source, you know, right? It's a connection pool implementation from Sun Microsystems. So there is a data source class. For this data source, it's a connection pool implementation. Okay, for your information, this is a connection pool interface. Okay, So for this connection pool interface, many vendors given implementations. Archil, I mean database, not database vendor. Some third parties given connection pool implementations. So there is Apache, Commons database, Commons data source, and C3P0 basic data source. There are many implementations. Consider you have Archil here and MySQL DB here. You don't know in future which database you are going to use. Okay. So what I'll do here, I'll implement a factory. Factory will give me that flexibility to change the database in future. Factory, you implement your own factory here. DB factory. DB factory. This DB factory will do what? Here it will create connection pool. Basically, as I said, right? Factories will not create its own object. Instead of creating its own object, they will create the factory method returned objects. So here I have one method, static get db get db connection pool method I have. Get db connection pool method I have here. So inside this get db connection pool, I'll decide that I may create object for Apache connection pool or C3P0 connection pool. There are many implementations. Okay, there are many implementations. I can use this implementation or this implementation. Depends on the requirement. I can change it also. Today I can go with Apache, and if I see some problems, I can shift it to C3P0. Tomorrow, if there is a new vendor providing any connection pool implementations, like WebLogic providing some open source, I can go with WebLogic implementations, WebLogic connection pool implementations, anything which I should able to easily I should able to change my connection pool implementations. So here is a factory. This factory is having a get db connection pool object. I want to use this connection pool object here in my DAO. I want to inject this connection pool. I want to inject whatever connection pool it created, right? I want to inject that connection pool into my DAO so that my DAO is independent of connection pools, right? It can be Apache connection pool or C3P0 or WebLogic connection pool. And that too, the connection pools, right? Apache can create connections for Archil database or MySQL database. Whatever connection pool you use, that connection pool can use any database. Okay. So there also they given that flexibility. We can set the properties of Archil database or MySQL database. Depends on the database which you use. That database connection pool only will create. And this factory we can able to create Apache data source or C3P0 data source or WebLogic data source, and it can able to inject that into my DAO class. So my DAO class is now independent of data sources. To make my application independent of data sources, I'm creating this DB factory. Okay, so I'm creating this DB factory to make my application independent of connection pool implementation. The same way, right? Here driver manager also they implemented. The same way the driver manager also implemented. Driver manager will help us. Driver manager will help us to make your class independent of connection providers. Archil given connection, MySQL given connection, DB2 given connection. So any database you use, we use the similar logic, same logic. So to make your application independent of database vendor provider implementations, this factory given, okay? So these factories we can implement, in a multiple ways. The one way that we discussed yesterday is factory method. The one way which we discussed yesterday is factory method. Using this factory method, we can implement. This factory. There is one more approach. Right? Factory bean approach. Factory method approach and factory bean approach. We have a factory bean. Factory bean is an interface. Using this factory bean interface also we can provide factory implementations. So the same example, right? Yesterday, which example we see this for factories? For this factory method. So here we used engine as an interface, considering it as a connection. Okay, and like a driver manager we created like driver manager dot get connection, we created a engine factory, get engine. So this engine factory get engine could able to create any engine implementation object. If you consider this is like a connection, this is a driver manager, and the driver manager would be creating objects for any database. Consider this is like a Oracle database connection, and this is like a MySQL database connection. Okay, here your application is consuming it in car class. In car class, we are consuming it. In car class, we are using engine. This engine can be anything. It can be Fiat engine or Suzuki engine. So during runtime, we are deciding. During runtime, we are deciding here using this factory. So this factory being, there is a factory method get engine will return a engine object which can be any implementation. Which can be any implementation which we passed here. It can be a Fiat engine or Suzuki engine. So that engine we are injecting into car class. So in case if you want to change it in future, we can change that implementation here, Suzuki to Fiat, so that it will start using Fiat engine. Okay, this is how you can implement factory class. So here if you see factory method concept we are using. So we implemented a factory class. In this factory class, there is a static method. There is a static method, and this static method we are configuring it as a factory bean. Instead of this, right, you can implement your factory from factory bean also. I'll implement one more factory here using factory bean engine factory using FB factory bean. Just you need to implement this from factory bean interface. There is an interface name called factory bean. Use this factory bean interface. Okay, use this factory bean interface and override all three methods. There are three methods in this factory bean. One is get object method, one is get object type, and one is singleton. So this is the main important method, get object method. So here if you see, this is the factory, right? This is the factory get engine method. This get engine method is creating the engine object based on the engine name we have given during runtime. Okay, so the same thing, same stuff we do in this factory bean get object method. And as these are dynamic methods, you really need not to worry about static context. So you can inject this value into factory bean. Factory bean is having get object method is a non-static method, so that these dependencies can be non-static dependencies. And you can create object here inside get object method. Inside get object method, create your engine class object, and which object you are returning, get object type. Always I am returning engine object type. So just you need to mention that class here. And do you want to create only one object using this factory? Factory can be a prototype factory or it can be a singleton factory. If you leave it as false, it can be a prototype, which means always when you call engine, it will create new engine object. It will create new engine object. If you want to make it singleton, make it true. So that only one engine object will be created. Only one engine object will be created. Now, how to configure this factory bean here? So while using this factory method concept, what we did, as this is a static method, this static method needs this class name. So as I cannot able to do static variable dependency injection directly here, I'm using a third party, I'm using a other class method invoking factory bean to pass my static arguments here. This is for passing static arguments to my class. But now you don't have that dependency. While using this factory bean, right? Factory bean concept, consider engine 1 I am creating, engine factory using factory bean. You need not to put any factory method here. Now when somebody see this statement, okay, when somebody who know very basic about Spring, when somebody see this statement, they will think that this engine 1 reference means it is creating object for engine factory class. Okay, so even if you see first time also, what you will think that, okay, this engine is the reference for this object, but not. This engine one is not reference for this engine factory bean object. This engine one reference is for this object, whatever you are returning here, right? If you return here Suzuki object, that is the Suzuki object reference. If you return Fiat, then this is the Fiat object. So we need to pass that Suzuki or Fiat value here using setter method. We have a setter method here. In this factory bin, we have set engine provider setter method. So here you just need to set that property engine provider value. You can pass the engine provider name beans dot Fiat engine or Suzuki engine. So when you use this engine one reference means engine one is not the reference for this object. Engine one is the reference for this object, Fiat engine object. So that's how factory will help us. You can inject the engine one here. Now we are using which factory? The engine factory bin, which is implemented from factory bin interface. So this is the second approach. Okay, either using static method or else by using this approach also you can create. Then when you start car, excuse me, Fiat engine it is using. Okay, as we injected this engine one using factory bin. So these two are the concepts for factory. These two are the concepts for the factory. So if I have problem in understanding, it's okay. Okay, we'll get more realization while doing examples, right? Going forward, we are going to use this factory bin in multiple places. We will realize this. Okay, don't worry if you have hard to understand this. Are we clear? Okay, so these two are the approaches. These two are the approaches for creating factories. Our own factories we can create. Okay, now I'm going to show you, you know a few other concepts. Okay, so the one is method replacer concept. Method replacer. So how this method replacer concept is useful is, see, I have some existing API implementation. I have, you joined into a project, there you have already existing implementation. Okay, there you have already existing implementation, and the team requested you to change the implementation in the existing code. Okay, change the implementation in the existing code. Okay, so generally, right, consider you join into a banking application and there is a calculate interest method. Okay, so the client suggested that the interest rate is changed from 10% to 9% only. So go and change that logic. So what you need to do, straight away you should come to this bank class, you need to change that logic here. In general, right, this is the way that we do. In Spring we have one beautiful concept, right? We have one beautiful concept here, that without touching this code here, on the fly you can do changes for this logic. On the fly you can do changes to this logic, right? You can override this. In simple words, you can override this by using method replacer. So in the name itself we have method replacer, right? So you need to provide one more implementation by using method replacer. There is an interface name called method replacer. Using this method replacer, for whichever method you want to change the implementation, that method implementation you can put here, the new implementation. So in previous, the calculate interest method is having this statement, interest calculation. So if I take something, or if I deposit amount, right? For deposit, this is the calculate interest. I am depositing like 1 lakh here, 1 lakh into 10 divided by 100. It will calculate the interest, whatever the interest for that 1 lakh. So it will return that interest here. I want to increase that interest rate, or I want to decrease that interest rate. Okay, instead of editing this class directly, what you can do, you can provide a separate implementation for only particular to your calculate interest method, using this method replacer concept. Okay, using this method replacer concept. So when you use this method replacer, okay, you can put your required new implementation here. So this is the interest calculation, new implementation calculation we are doing here. Okay, so and finally returning the interest rate, same thing, calculating it and returning it, calculating interest rate and returning it. How it will override? So during configuration, what we will do, we will suggest for that so and so calculate method, I implemented a replacer. So here if you see, I created my replacer bean, and already this bean will be there, right? Already this banking application bean will be there. In that bean tag, what you need to do, there is a tag name called replaced method. Replaced method. For which method replaced? Calculate interest method. Suggested me to change this calculate interest method. So here is my method calculate interest. For this calculate interest, this is the replacer. So here I need to configure that replacer, so that what it will do while executing this bank class calculate interest method, the execution will be bypassed from here. Instead of executing calculate interest method, the execution will be bypassed from here, and it will execute my replacer class replace method. Okay, my replacer class replace method. Simple. Okay, method replacer, how to understand is, as I told you, you have a existing class. You have existing class and some methods you have here. Public calculate interest, public deposit. So we have two methods. Now requested us to change this existing method. This existing method we are continuing since long. We want to change this implementation. Okay, we want to change this implementation. Earlier the code we have like this: bean tag, ID, bank class, class name, bank. So wherever you are using this bank class reference B, it could able to allow you to call calculate interest or deposit methods. So since long we are using this bank class, these two methods, calculate interest, deposit method. So now out of these two, one method they requested us to change. One method, this method implementation, they requested us to change. Now I don't want touch this method. Now I don't want touch this method, and I don't want corrupt the class which is existing. I want to keep that class as it is, and I want to replace that method code on the fly. So now what you need to do, you need to implement one replacer. For each method, you need to implement one replacer. Class calculate interest replacer, and you need to implement this from method replacer. You need to implement this class from method replacer. So when you try to implement it from method replacer, there is a replace method. Public object replace method. You need to override this method, and the override logic, I mean the logic which you want to override for calculate interest. New calculate interest logic you need to write here. New calculate interest logic you need to write here. And now in configurations, what you need to do? In configurations, what you need to do is create your replacer object here, bean ID, the replacer reference, class name, your calculate interest replacer, whatever the class name is, replacer, and just you need to pass this replacer reference here. Here we have one tag name called replace method. Replace method, right? We have a tag name called replace method. So in that replace method, what you need to do? You need to pass your existing method name. Which method you want to override? The method name you need to pass here. The method name is cal interest, int, and I want to override that with the replacer. Replacer reference is R. Okay. Spring will do what internally? It will create a bank class proxy object. Earlier it used to use simple bank object, right? Now onwards it will start using bank class proxy object. So which means not the original object. It will create a proxy at runtime, right? Spring will create one more new class, runtime class it will generate. In that runtime class, right, instead of using this calculate interest method, it will use this logic. Instead of using existing logic, it will use new logic. Okay, a simple concept to replace existing method. This is a simple concept to replace existing methods logic. Okay, let us go and see this example. This is interesting, right? Instead of editing the existing code, we can directly yeah. So this is the existing bank class, and this is the method that we have. Two methods, deposit and interest method. Deposit method is using calculate interest method to do calculate operations. Let me put one more statement here. Old calculate interest method. Now configure your bank class here. I'm not putting any replacer, just commenting it. I have a bank class method here. I mean bank class I configured there, and loading the bank class, and getting the bank class bean object, and calling the deposit method 5,000 deposit. Old calculate interest method, which means whatever we have there, that interest method is executing, and for 5,000 interest calculated 10% and it became 5,500. Right, 10% interest means 500, so the 500 added to this deposit. And if you print your class name, whatever class you implemented, the same class name only it will print, because we are not proxying it. Okay, the class name we are trying to printing, so it is saying it's a beans dot bank class, so our class name also proper name only. Now I want to implement a replacer. So write a class by implementing from method replacer. So yeah, the method name is reimplement. Okay, do a reimplement method here. So this reimplement method will have three arguments. One is object, and one is method, and one is parents. Why these three arguments are here? Means this calculate interest method I want to override. So here this method is having argument amount. How you will get that amount here? I'm trying to providing new implementation, right? Your new implementation also need parameters, right? So your methods can have any number of parameters. Any number of parameters method you can override. So all that parameters will give in the form of object array. So that as I am sending only one parameter, right, using zeroth index, I'm getting my amount and doing the calculation. This is new interest rate method. And finally, I'm returning it. So now this method replacer object you need to create first. And using this replace method, for whatever method you want to provide substitution, right? That method name you need to put here, and your replacer reference you need to put here. Okay, now try to run this. Now the interest rate changed to 20%, right? New interest rate method is executed, old method not executed. So actually what I'm trying to calling b dot deposit method. B dot deposit method internally calling calculate interest. So I'm calling a calculate interest method. The call should go here, but it is not going there. Instead of going here, the call is going to this reimplement method. So at runtime, new implementation given. At runtime, Spring given new implementation by proxying your bank object. If you see here, it is printing class name. I'm trying to getting the class name. It is saying beans.bank enhanced by CGLib. Some other class created. See, this class we didn't created. We don't have any such class here in the beans, but it created during runtime. One proxy class created. In that proxy class, it override your old logic with new logic. So that instead of getting 5,500, we are getting 6,000. The new implementation calculation interest rate we are getting here. Okay. So this is how method replacer will work. Okay, to replace the existing methods, we use this. Okay, rarely we use. I didn't see any case that I used this one in my experience. If you need anything, if you want to override anything, right? If you want to override anything from the existing classes, you can use it. Okay, comfortably you can use it. It will do proxy. It will do a proxy creation. Using that proxy only, it will execute when you configure method replacer. If you don't configure any method replacer, a simple class only will be executed. Okay, yeah. The next we'll go with aware interfaces. Okay, aware interfaces, and we have events handling also, right? We'll see event handling also. So we have multiple events handlers for our IOC container. Okay, we have multiple event handlers. Event handling means what? If you know about the listeners, right? If you know about listeners, servlet listeners, we have a servlet startup listener, servlet stop listener. We used to implement multiple listeners, right? How listeners will work whenever you start your container. If you want to do something, right? Generally, I have a Tomcat container. I have Tomcat container, right? So in Tomcat, we can deploy servlets. You can deploy your code here using servlets. You can implement servlets logic here. We can implement servlets here. Tomcat will create your servlet objects. Okay, it will create servlet objects, and you can execute do get or do post methods, whatever you have in this servlet class, do get or do post methods. Along with servlets, we can have filters. Before servlets, if you want to execute something, during request only, user wants to call do get method or do post method. But if you want to do some validations, you can apply filter here. Inside filter, you can do validations. You can do validations or security things by using filter. Apart from this, right, before servlets or before filters, while starting my Tomcat, I want to do some initializations. In my code, I'm using some connections, and that connections I need to bring from some database. I want to create some connection pool. So I want to make it ready before initializing my servlets or before starting my servlets or filters execution. I want to execute something so that in servlets we have concepts called listener. So listeners will execute first before your servlets. So when you start Tomcat, you can have a start listener. Tomcat startup listener. You can implement one listener here. The listener will listen when you start it, right? It will listen your request. Listener. You can implement a listener. In that listener init method, you can do required init operations. You can do required init operations. So this listener will call at the time of startup. So here itself we can have init method and destroy method. When you shut down it, listener destroy will execute. Listener is the first class will start. Listener is the last class will destroy. Okay. Listener is the first and last class. So before application start itself, if you want to ready some infrastructure, we use listeners to start it. Okay. Similar way, when you implement your application using Spring application is running on IOC, and we implement all our classes as posers here. We implement all our classes as posers here. We implement all classes as posers here. Before executing your controller classes, controller poso, or it's a service or a DAO, whatever it is, right? It can be a controller or a service or a DAO. Before executing your classes or before starting this poser classes itself, if you want to execute some listeners, we have that listeners here. Okay, event start listener, right? Before starting your container, and when you want to refresh your container, during refresh time, if you want to execute, during shutdown time, if you want to execute some listener, right? During stop method, if you want to execute some listener, there are multiple types of listeners we have here, right? When you start event, or when you stop event, or when you refresh event, or when you close event. Okay, we have multiple listeners here. Okay, so see how we implement it. Start event. To implement a start event, we have application listener class. So just right, it's a listener. We implemented some event here. Any pre-operations before your application, if you want to do any pre-operations, we do here. This will execute during starting time, during your container starting time. And there is a stop event. If you implement something here, this is also implemented from application listener, and the type is context stop event. So when you stop your context, application context, there is a stop method. When you call stop method, it will execute this method. And when you refresh it, if you want to execute some listener, then you can implement that particular case by using application context listener only by using context refresh event class. So when you refresh your method, or when you refresh your context refresh method, these statements will be executed. And close event. When you close your container, if you want to execute something, you need to implement it from application listener context close event. So that closing implementations you can have here. Okay. So finally, right, when you start your application context, right? Finally, when you start your application context, it will call start listener. When you call stop method, it will call stop listener. When you call refresh, it will call refresh listener. When you call close, it will call close listener. But all this stuff is going to executed. So in case if you want to execute them before itself, before your beans creation itself, you can call these methods so that all your context listeners will be executed first and they will be ready. Okay. So just get it into here and see how they will execute. Event handlers. Okay. So these all are our listener classes. So for starting event, we have start event listener implemented from context to start event. Implementation will not change. For all the events, we do the same kind of implementation. Only this context class will change. Context started event means when you start your application context. Okay. This will execute when you start your application context, and stop when you call your stop method on application context. And this is the close one, implemented from context close event. When you call close, it will execute. When you call refresh, if you want to execute something, you need to implement from context refresh event. Okay. So just I configured all these events classes here: start, close, stop. In any order you configure them. Now to understand that listeners, right, you need to use configurable application context. We need to use configurable application context. We need to use configurable application context. And I'm not calling any method. Just starting my context. Just starting my context. And on start by default it is calling. On context refresh call, right? While loading your XML, these two statements are executing from on start method. This is not executed, right? Is this? No. Start event not executed. While closing, this one also not executed. The refresh one executed. The refresh one only will execute during starting time. Refresh one will execute during starting time. Okay. So when you load your XML during loading time and as well as during refresh time also. While loading itself, it is calling refresh event. Okay. So while loading, these two statements are executing on context to refresh call or else while loading your XML. In both the context, the refresh event will execute. So if I call the refresh method one more time, it will execute the same statements again. So your refresh listener executed during starting time and whenever you want to refresh it. So during the refresh time also you can call it. It will call it basically. Now start event. When you want to call start event particularly, you need to call cap.start. So after refresh event, it will call the start method. After refresh event, it will call the start method. If you want to stop it, you need to call context stop method. So on stop, listener will be executed. The stop listener will be executed. If you want to shut down your container, you need to call cap.close. Cap.close. Yeah. So during loading time, refresh called. When you call start method, start called. When you call stop method, stop called. And during closing time, this one is called. So this is how, while during this application start or stop or refresh or closing, for this particular events, if you want to write any logic, you can implement this event handlings to implement that scope here. Okay, to implement that logic here. Are we clear? We will not get that much scope to implement them. Okay, these are less priority. These are less priority to us. Okay, just for your interview sake, we are discussing all this here. So in case if you have really any such use case, you can go with this event handlers. We have 4 event handlers: refresh, start, stop, and close. Refresh, start, stop, close. We can have these 4 event listeners. These event listeners will listen your application context methods. When you call application context, I mean directly when you start your application context. When you start your application context, right? When you start your application context, refresh will be default executed, and the other listener, start listener, will execute when you call start method on the cap. I mean your application context. When you call stop method, it will call stop listener. When you call refresh method, again it will call refresh. When you call close, it will call close listener. Okay. Apart from this, method refresher executed. Yeah, and there is a aware interface also we have. Aware. So this is also one important one, aware one. Okay. Uh, so this is the one, right, that I was saying in interviews. They are trying to confusing us. I'll tell you that question. Okay. Uh, Let me add jar files. So here I have 2 classes, car and engine. I'm doing simple dependency injection of engine into car class. This is my car class. Okay. And this car class is having engine dependency. Okay. So yeah, instead of injecting the engine, if any bean class, if it wants, if any bean class if it wants, another, if any bean class if it wants application context object itself. Okay. So throughout application we implement many classes, right? Throughout application we implement many classes. So if any class wants application context itself, what we have in the application context? I have controllers, services, DAO classes. All these classes will be loaded into your context area. Into application context only, we are loading them. Into application context only, we are loading all these classes, controllers or services or DAOs. Services or DAOs, we are loading them into application context only. If any one of this class wants this context object itself, okay, if any one of this class wants this context object itself, context is having many methods, right? Context is having many methods. If one of your object, if they want this object as a dependency, if any one of your class, if they want this context object itself as a dependency to you, the container itself is a dependency for you. If a container, if you want use as a dependency in your class, there is an application context aware. There is an application context aware. By implementing this aware interface, what you can get is there is a method name called set application context. If any class needs application context itself as a dependency in your class, so you can create application context as a dependency in your class, application context. So now if you want to inject that, you need to implement your class from application context aware. So then it will ask you to override the setter method. You know how to do setter dependency injection. So set application context. So this application context object will be injected here, but you need not to do this. We are not going to do this. Application context object injection, who will do? Container only will do. You are not going to call this. So if you see the XML here, we created engine class object and car class object. Inside car class, I have engine dependency. So who will maintain this engine class object, car class object? Your application context only. So inside car class, I want to use application context to get the engine class object. I want to get engine class object by using application context only. Okay. So now what I'm doing, this application context aware I'm implementing so that my car class is getting application context object itself here. You know, right? If you have application context object, how to get other class objects. So I have a drive method in my car class. Here I'm getting ap.getBean of the engine so that I'll get the engine object. Now using that engine object, I'm calling engine class model here. But right away, I'm not doing any dependency injection here. I'm not doing any dependency injection here. Using application context, I'm getting engine class object. Okay. Using application context, I'm getting this engine class object. And finally, when you run it, car RD drive using engine model 2015. This 2015 is set here in this engine, but how this engine is available in car class? I didn't injected it. I didn't injected it as container itself is injected to my car class as container dependency itself injected into my car class. Using this container dependency, I can call any bean which is configured here. I can call any bean which is configured here. You can call any bean here, and you can use. I can get that bean object and I can consume it here. Okay. So in interviews, I got this question, right? In interviews, I got this question. One question is, by default, you know the scope of these classes, right? Car class scope or engine class scope. By default, the scope of these classes is singleton. Okay, by default, the scope of these classes is singleton. Let me override constructor here and put the car object. And in engine class also, override default constructor, put a statement. Oh, engine object. So by default, these two objects are singletons. By default, these two objects are singletons. So engine class object created, car class object created, and car RD driving using engine object. Okay. Now I want to make this engine classes prototype. I want to make this engine classes prototype. So let's make it to scope to prototype. Prototype. Now when I try to call this drive method multiple times, drive 1, drive 2, drive 3, drive 4, 4 times I'm calling. So see how many car objects created? One car object created, and during c dot drive method we are calling get bean of engine object. So while we are calling that drive method, every time engine object is creating 1, 2, 3, 4 times. 4 times your engine object is created. Okay. So when any singleton class is having prototype dependency, in some scenarios, right, a singleton class can have a prototype dependency. A singleton class method can have a prototype dependency. If you find such scenarios, right, you need to implement this application context, and using this application context to dot get bean method, when you call only, the prototype scenario will work, otherwise it will not work. Let me give the same example in other way, you will realize it. So we did the without aware, right? Without aware, I'll implement this singleton versus prototype. Singleton versus prototype. In general, right, when somebody give you requirement that I need a car object, or in general in your MVC, right, in your MVC, the requirement might be like this, right? My controllers are singletons, or my services are singletons, but I don't want to maintain DO as a singleton. For every request, whenever user pass some data, for every request, for every user request DO object I want to create, a new object I want to generate for every request. In general, controller service objects or DO objects, all your objects are singleton. But for every user request, I want to create a brand new object. For every request, I want to create a brand new object for a particular class. Okay. I want to maintain my controller. I have a registration form here. I have a registration form here. Enter name, email, address, some data I'm getting from the registration form. When user submit this data, the data will hit the controller. I want to maintain one controller only. Controller object I don't want to create for every request new brand new controller object. One controller only, one object is enough. From my architecture, one object is enough for me here. But this controller is calling a service or a DAO. Consider controller is calling a helper class, a helper class, a helper class you have. And this helper class object I want to create for every request. When I call this registration form, the registration form data will go to controller, and this controller should able to create a brand new object for every request. Here 10 users if they request, 10 users if they request, if 10 users request, controller object should be only one, but this helper class objects I need 10 objects, 10 helper class objects I need, which means your controller is singleton, your controller is singleton, and the helper is prototype. The helper is prototype. This is the scenario. This is the scenario. Okay. This is the scenario they want. You need to maintain one singleton class, and that singleton class should be able to consume a prototype class. Using traditional approach without this aware interfaces, if you try to implement it, right, see what will happen. You cannot able to achieve this. Let me take the same scenario, right? I have a car class. I want to use engine class into car class. Excuse me, just a minute. Excuse me. Now, in my car class, in my car class, I don't want. do this aware and all. I just need this engine class object. Engine. We use set engine method, right, to inject this a setter method I have. This is the general approach that we follow. We create our variable reference and we put a setter method and we use that object here wherever you want to call that particular class methods. So I have a car class and an engine class. I have a car class and an engine class. Let's configure both into a XML file. So this is my engine class. I mentioned it prototype. Car class is default singleton. Though if you mention scope or not, by default it is singleton. Default scope is singleton. Now call drive method. Calling drive method 4 times. So my requirement is for every request, one car object, multiple engine objects. So the first thing is what happened. As you mentioned it prototype, okay, you did not injected it. Sorry. As we mentioned setter dependency injection, right? You need to inject it. Prototype object, right? The dependency is engine reference, engine reference. So if you see here, one car object created, one engine object created. Whenever you call this drive method 4 times or 100 times, it is not reflecting engine as a prototype. Though you configured it as prototype also, when prototype injected into singleton, the prototype behavior also become a singleton behavior. Then how I am achieving prototype scope here? My engine class scope, I mentioned it prototype. So for every request, the object need to be created, brand new object, but it is not happening because we injected prototype object into singleton. Then what will happen? The prototype also will become singleton. The prototype, as this object is creating only one time, while creating this car class object, Spring will create one engine object and it will supply into it. Thereafter, car class object is not at all going to create, so that it will not touch about your engine reference also. Whatever engine reference created, that engine it will maintain it as a singleton and it will continue it. Though you configured it prototype, no use. Still it is behaving like a singleton only. So that is the reason this aware interface given. So what is happening here? In general, when this engine object will create multiple times, when you call it externally, ap.getBean of engine reference, if I call multiple times, then the prototype works. But when prototype injected into singleton, this not work. So until unless you call this getBean method, it is not creating engine class objects. So somehow it is compromising the prototype rule. So then they thought, why can't we call this ap.getBean method from drive method itself? If you want to call engine, this getBean method you need to call. When you call this getBean method, then prototype is working. So inside this drive method, I should able to call the same thing, ap.getBean, application context.getBean. Okay, the same statement I should able to call there, so that whenever you call this drive method, for each call, I will call this application context.getBean method, so that I would be getting engine object here, so that the engine object is a prototype. Engine object can become like a prototype. But how you can get this application context object here? So to get the application context object, what you need to do is you need to implement your class from application context aware. When you implement it from application context aware, it will ask you to override a method set application context. It will provide you application context object AP. Now what you can do, you create application context reference here and assign this there. This dot AP equal to AP, application context. Now you really need not to worry about this engine dependency injection. You should not do the dependency injection, because if you do the dependency injection, the scope is compromised. So don't do dependency injection. Wherever you need the prototype object, use the aware implementation. Use the aware implementation. This aware is providing context object. Using this context object, I'm getting my bean. So while you are calling this drive method will do ap.getBean. When you call this getBean method, as this bean is prototype, for every request it will create new object. So that now you could able to make singleton with prototype dependency. Car object, while you are calling drive method, one brand new engine object created and it is executed. Again, when you call drive, once again new object, again new object, new object. For every call it is calling getBean method and creating a new engine object. Okay. So this is the question, right? They are asking, when you have a singleton, object, when you have singleton object with dependency of prototype, how you can achieve it? If you do direct dependency injection, will that be a singleton or prototype? If you do direct dependency injection, though you configured your engine object as prototype also, that will behave like a singleton. Okay. So to achieve this scenario, what you need to do is, as we need to call application context dot getBean method. Until unless you call this getBean method, it will not create a prototype bean. So to get the application context object into your class, you need to implement your class from application context aware, so that whatever application context object it created, that object will supply to you. Okay, this object will be supplied to you. So during runtime, when you call drive method using this context object, you can call getBean method of prototype, so that for every call it will create a brand new object. That object you can use. Simple, right? Yeah, this is how we can achieve singleton versus prototype when you have singleton object with prototype dependency. Are we clear? Hello?
Yes, sir.
Yeah, yeah, sure. So I think I didn't send these examples to you. What I will do, as you know which example we are discussing, right? I'm going to send you these 59 examples. Okay, the basic core concepts and all we have here. Okay, so based on the concept that we discussed on the daily basis, right? Just import that example and do practice. Almost all the core concepts, almost 40 plus examples we have for discussing core concepts. Okay, go with them. Up to awares we discussed, right? Tomorrow or from Monday we will start with JDBC. We'll start the JDBC module. Almost we are done with Spring Core module. Okay, we are done with Spring Core module. Just do all the core examples. Okay, just practice all the core examples. Okay, and from tomorrow onwards, right, basically those are all concepts, simple concepts, like how to use JDBC, how to use ORM, how to use MVC, AOP. Those are all simple concepts, real-time concepts that we implement. Okay, just focus this weekend on just refreshing all the core concepts till now what we discussed. The main important things that you need to remember is dependency injection and the stereotypes. Remaining all we are not going to use anywhere. Just for your knowledge sake we discussed. Okay. So if you are clear, okay, I'll send these examples. Okay, do practice tomorrow and day after tomorrow. Monday we'll connect back by 8:30 only. Okay, 8:32. We'll continue up to 9:30 or 10 o'clock.
Yes, sir.
Yeah, that's all. Yeah, thanks guys.